Hello everyone, welcome to the session. So in this particular video, we will talk about the implementation of breast cancer detection. Given a data set, so basically we need to classify that whether the cancer will belong to B class or M class by saying that benign or malignant. I'll try to show you the data set first of all, and then we will try to see the implementation for the same. We will try to compare different classification algorithms that we have in machine learning, and we'll try to see the performance, which one is working better. So here I'll just show you maybe one or two algorithms, and remaining I'll give you as an assignment. Perfect. And then you need to let me know that which particular algorithm is working really good in this particular part. So first of all, as I always say, we just need to import all the required libraries. So the very first task is to import all the required libraries. So here what we can say, import numpy as np. We can import pandas as pd. We can import seaborn as sns, right? And we can import matplotlib.pyplot as plt. Perfect. I think this is enough. If we further require more libraries, then we will do at that point of time itself. Now what I can do is that I can first of all read the data set. So what is the data that is given to us? So data is equals to pd.read_csv, and here inside that I can mention the path of the data, which is nothing but is equals to data.csv. So here we just copy this path, and then we can say data.head. And if we run this particular code, we will be able to get that, okay, we all know that whenever we are calling this head function, first of all, we will be able to get a topmost 5 records. Perfect. Now, here if you will see, we will be having the ID, diagnosis, radius mean, texture mean, and so on until the last factor, which is unnamed 32. It's all nan, I believe. So overall, we will delete this column. I didn't find taking this column any sense, right? So basically, if you will see, this is something which I can consider as the target column, where either the category will be M or B. I can show you also. So here if you will see, if I will say data of diagnosis, and I think if we will take the set of that, we will be able to get the classes, right? Unique classes. So if we will set of this, we will be easily able to get that. I hope that the spelling is correct. So here, as I am saying, B and M, these are the two classes that we can see here, right? Now, if suppose I want to see the shape of my data, if I want to see the shape of the given data, so how we can say? So simple data.shape. If we call this particular function, we will be able to get a point that here we will be having 569 number of rows, and in total we will be having 33 number of columns, right? If suppose I want to check the sum of nan or null values, sum of null values in the given data set, so how we can do? We can simply say data dot, I would say, is null dot sum, correct? So here we will be able to get that how many null values are there. So we can see that, as I was very much suspicious also about this column, I told you that this column is something which I thought contains all the nan values, and that is something which is happening here. So we will be having 569 rows in total, and 569 in all the rows I am getting the value as nan. So it would be better that if we will drop this particular thing. So in order to drop that, what we can say is that data is equals to data.drop na, and here we can mention the axis, which is equals to 1. Perfect. So if I will do like this, and now if I will check the data.isNull again, so you will observe that now we will be able to get rid of that particular thing, right? So the last column, which was unnamed thing, was not there. I think unnamed 32, it's not there, right? So now we will be somehow able to remove the null values as well. Suppose I want to see the count plot of, or the value count of this different classes that we have. So what we can do is that SNS, or you can say data of which class that you want to go for diagnosis, right? Diagnosis, and here you can mention value underscore counts, right? If I run this, so we will be able to get an idea that the performance or the data that we have, where the class B, benign class, is having 357 records, malignant class is having 212 records. And in total, how many number of records do we have? Here if you will see, we will be having 569 number of records that we have, correct? Now, we can call the count plot as well. This count plot, what it will do is that it will try to see diagnosis. So I think it is fine, right? And here we can mention that what is the label that we want to show here. For example, count. Now, here with the help of a count plot, we can simply visualize as well. So basically what I did here is that visualization using the count plot method, right? So this is what we have done. I hope that this is also making sense to everyone. Suppose I want to check the data types of each and every feature that I have. So what we want to do is that I want to see the data type of every feature. For that, what we can do is that we can simply say data.d types, right? And if we run this, we will be able to get the type of each and every feature. Now, we all know that there is only, I can see one feature which is of object type. Apart from that, whatsoever remaining features that I have will belong to that float data type. So that is not an issue. But this object type is something which I want to map to 0 or 1, right? Because it is a categorical kind of a feature and I want to convert it into a numeric one. So there are two techniques that we are aware of to handle that thing. Either we can go for one-hot encoding or we can go for label encoding. As I have only two set of classes, so what I can do is that I can just apply a label encoding on diagnosis feature. Fine. So what I can do here is that I can say from sklearn.preprocessing, I can import simply the label encoder here. Fine. I can import simply the label encoder here. And after that, you can make an object of the same method. So label encoder, which is equals to label encoder. And after that, you can simply say, so which particular column you want to do the label encoding. So you can just extract that column using ilog function. You can say all the rows and the first column, because here if you will see, this is the ID is the 0th column and diagnosis is the first column that we have. So I want to apply label encoding on that particular row. So here what I can do, I can say label encoder dot what we can do fit underscore transform on what particular data, so I can copy this completely. So this particular data dot values. So in this way, we will be able to convert our data or map our data values of M and B in the form of a 0 and 1. So if I will show you this particular thing, what it is doing. So if I want to show you this thing as a print statement, so I think I can simply show you this as well. Let's see what we will be able to get here. So now here if you will see, I am getting the values as 1, right? Initially, if you will observe, it was M and B. So here it clearly suggests that the value M with respect to 0 index. So here what you can say is that now we have mapped the value M with a 1 and B class as the value 0. So this kind of mapping is what we have done here. Correct? I hope that this is making sense to everyone. Now, what we can do further, I want to find out the correlation matrix of the features that we have inside this data. So correlation matrix of all the features inside the given data set that we have. So how we can do that? We can say plt.figure. Here, in order to increase the fig size, we can use fig size, which is equals to, I can say maybe 20, 20. And here we can call our SNS method, sns.heatmap. Inside that, we can say data.correlation to find out that correlation coefficient, and we can make the annotation as well is equals to true. So if I will do like this, I will be easily able to get the correlation matrix where each and every particular number will simply indicate the correlation coefficient. Now we all know the importance of this matrix. If suppose there is a feature, there are two features which are generating a high correlation coefficient. So what we can do in that particular scenario? In other words, we can say that at that point of time, somehow they want to deliver the similar kind of information, can I say? And if that is the scenario, what I can do is that I can just remove few features which are having a higher correlation coefficient and will take only single feature, right? Why to increase the dimensions? Because by increasing the dimensions, you are increasing somehow the time required to train the model. And obviously, if there is some advantage of doing that, we will do. But if there is no advantage of something like that, then why are we supposed to do that, right? So here, now what we can do here is that we can simply, if you want, you can also save this figure by saying save fig. And here you can say this is something which you have as a correlation values.png. So if you want, you can save as well. And here, in order to do the better visualization of the values, the file will be saved here. You can download also. And at your home, what you can do is that you can just clearly see after downloading. If I will open this, just try to observe and do let me know that which are the features which you think is having a higher correlation coefficient. For example, here if you will see, I am seeing the values of 0.94. I am also seeing the values of 0.97. I can also see the values of 0.96. So these are the features which you can say is having a high correlation coefficient, right? So this is a task which I want everyone to do. And what you can do here is that your task is simply to remove the features and take only single feature at the time when the correlation coefficient is really high, right? So this is the thing that we're supposed to do here. So this is your task, is to do this particular thing. Perfect. Now what I can do is that I can just divide my data into two halves, where one is the input feature and another one is the target value, because I already did the mapping into 0 and 1. So what I can say is that X is the data features that we have. So what we can do, data.ilog, we can take all the values. Here I can say that all the values starting from second column until the last column, which is 31, I want to take all the features. So all the values I want to take. For Y, it is something where I want to take data.ilog, all the rows and only one column, right? Dot values, because I know the diagnosis is something which is the target value which I want. So you can run this. So here if you will observe, this X indicates the input feature, correct? And Y indicates the target value. Perfect. Now what we can do is that the next important step is to do the data splitting. Next important step is to do the data splitting. In that, what we can do is that from sklearn dot model underscore selection, we can import train test split. And after that, what we can do is that we can simply do the splitting, xtrain followed by xtest, followed by ytrain, followed by ytest, correct? And here we can say train test split, And here we can mention what is the value of x, what is the value of y, what is the test underscore size you want to take. By default it will be 0.2. Suppose I want to take 0.5. What is the random state I want to take? Suppose I want to take maybe 44. By saying random state, if you are mentioning the same value, 44 or 144, any value, so at that point of time the mapping of training and testing set will be same. That is the only thing that you can infer from this particular parameter called as random underscore state. If I run this, so here I will be able to split my data into training and testing. Now the next part which I want to do is scaling of all the features using standard scaler. Now what we can do here is that we can say from sklearn dot preprocessing, we can simply import standard scaler, right? We can say scale is something which is equals to standard scaler, and inside that we can say xtrain is something which is equals to scale dot fit underscore transform, and here we can pass the training data, and on the side of a x test we can say scale dot transform on the x test. Now one pretty obvious question which can be asked from you is that whenever you are doing a scaling, it doesn't matter whether you are doing using a standard scaler or a min-max scaler. First of all, what's the difference between those two? When we are talking about standard scaler, it is basically trying to convert the data into a standard scalar form where the mean is 0 and standard deviation is equals to 1. So how basically we usually converted any data into a standard scalar form? Using a z value, which is x minus mu by sigma. So basically it will try to first of all calculate the value of mu and sigma in order to do the conversion. That is something which came under the category of a fit part. When you are saying transform as well, so now it will start transforming all the data of yours into the value of x minus mu by sigma. That will be done on the training set. On the test set, what will happen? The same value we will use to transform the complete data. So that's the major reason. So now this part is also done. Now what I can do is that I want you guys to work on. Basically what I want is that I want to apply multiple classification, multiple machine learning classification models, okay, to solve this problem, to solve the classification problem. So now what I can do is that I can create one method called def models. Here I can pass the train data and the value of y train as well. Now suppose here I want to apply logistic regression. I want to train using the logistic regression. So how we can train? We can say from sklearn dot linear underscore model. Here we can simply import the values of logistic regression, and here what we can do is that we can say model underscore 1, which is equals to, here you can simply apply the logistic regression model, and then you can say model underscore 1 dot fit on the train data that we have, x train followed by y train, the similar way that we used to do for every kind of a data that we have. Similarly, suppose I want to do the training using the KNN classifier. For that, what we can do is that again we can call from sklearn dot neighbors, NEIGHBORS. I can import k neighbors, NEIGHBO. I hope the spelling is correct. Classifier. Now what we can do is that there is a model 2 that I am having, which is k neighbors classifier. So we will be able to get that. And now what we can do is that model underscore 2. So here it is sklearn, right? Dot we can do the fit method. We can use the fit method and we can say X train and the Y train. Similarly, what I want from you all, I want you all to now do one task here. Try to do the training using maybe Gaussian naive Bayes classifier. I want you guys to also work for training using a decision tree classifier. I want you all to train this model using a random forest classifier. Perfect. So I hope that you can do this very much easily. Now, suppose I want to print the accuracy. So I want to do the printing of the accuracy. So what we can say is that logistic regression accuracy is something which is equals to model underscore 1 dot score. And here we can mention training accuracy if we will see. So you can say logistic regression, training accuracy as of now, let's see, X train followed by the Y train. And similarly, we can here simply print the value of a, what I can say, KNN classifier training accuracy. And here again, what we can do is that we can say model underscore 2 dot score on the X train followed by the Y train. And now what you can do is that similarly you need to find out the training accuracy for all the remaining algorithms that we have mentioned here, right? Now if I run this particular code, let's see what we will be able to get. So what I can do here is that I can simply, I can simply return the model underscore 1 followed by the model underscore 2. Perfect. Now let me try to run this particular model now. Model is equals to, I will call this function models, and here I will pass X train followed by the Y train. So now if I will call this, I will be able to get the training accuracy as 98.59% for the logistic regression classifier and 98.12 as the KNN classifier. Now here if you will see, when I am talking about a training accuracy, I can observe that they are almost similar, right? But what matters to me the most is the test accuracy as well. So what I can do is that I can simply say from sklearn.metrics, I can import the classification report in order to generate that. From sklearn.metrics, I can also do one more thing. I can import maybe the accuracy score, right? That is also fine. Now what I can do is that I can make one for loop which will move until the length of the model that we have, right? And inside that what we can do is that we can simply print the model followed by the value of I until that many times obviously it will run. Suppose I want to print the classification report of my model. So what I can do here is that I can say maybe print I can call the function classification report, and inside that I can pass the test values. So here I can say Y test is the actual value, and what is the prediction here? Prediction will be something which is equals to model of I dot I can say predict on the X test. Perfect. So this is something with the help of which I will be able to generate the classification report here. Similarly, I want to print the accuracy report here. I want to print the accuracy report. So in that case, what you can do is that you can simply say print accuracy underscore score, and inside that what you can do is that you can similarly say Y test, and what is the value of Y pred? The value of Y pred will be something which is again equals to this particular thing, model of I dot predict X test. Perfect. Now if I will just do the printing of that, so I can do one more thing just to make it look like more spacious. I can just make one more print statement. So now here if you will see model 0, which was the logistic regression model, I will be able to get the value of precision, recall, F1 score and the support. Here if you will see on the class basis, you are getting individual precision, recall, F1 score kind of values. Similarly, model 1, which indicates the KNN classifier, we will be able to get different kind of things. Now, here if you will observe, this is the test accuracy, which is 98.60% in the logistic regression, whereas 95.804% in the, I would say, KNN classifier. So somehow we can clearly say here that logistic is somehow working better by seeing the results that we are getting, right? Suppose I want to print the predictions here. So suppose we want to do the predictions display for each model. So how we can do? Again, we can simply apply one for loop and things will be done. So what we can do here is that we can say for I in range, whatever be the length of the models that we have, right? We can say length of the model that we have, we can say y underscore pred is something which is equals to model of I dot, we can say predict whatever be the value of x test that we have. And now what we can do is that we can print the value of a y pred, correct? And after that you can, if you want, you can give a space as well, correct? And if you want, you can also, for the visualization purpose, print the value of x test. So here if I will run this code, if you will see, what I can do here is that I can give more space. So if you will see, this is the prediction for the logistic regression, and this is the actual value that I am able to get here, right? Y test. Similarly, this is the prediction for the I would say KNN classifier, and this is the actual values that I am getting. So basically, in this way, you can print for all the classifiers that you have, whether it be a naive Bayes classifier, decision tree classifier, and the random forest classifier. So basically, this is how there is a complete implementation for the detection or for the prediction part that we can do on this particular dataset that we have. Now the next important part, which we will discuss in our next upcoming class or the session, is model deployment using the Streamlit. So that we will do in our next upcoming session. But until so far, whatsoever we have discussed related to the implementation of breast cancer detection, right? Here one thing is this that you need to do, right? Another thing is that I didn't do much EDA task here. Obviously that requires a lot of time, and these things also I have told you what are the EDA part that we have. So I'm not basically utilizing that time here. Basically I want to show you the implementation of prediction part mainly here, and I want to show you that how basically we can implement multiple models in one go, and then we can compare the performance of each and every model. For example, here if you will observe, we have mentioned in the models method definition, a lot of models we can go, right? Now what we can do here is that at the very end, whichever model is working fine. For example, I would say random forest is working perfectly fine. So what usually happens is that we will try to save the model file of that random forest in the form of a pickle file. And then that particular file I will use for the deployment purpose, so that the further predictions will happen for this particular model only, right? So basically for the comparison, we can go for multiple models and we can just try to compare the performance of those models. Whichever model will perform better, we can take the pickle file of that and we'll use that file for the prediction purpose. So this is the overall idea behind the implementation of the breast cancer detection part. If you still have any sort of doubt, do let me know. For sure, I'll try to resolve it as soon as possible. With this, happy learning to all. Bye-bye everyone, and I'll see you all in my next upcoming video.